Factoring special cases. This is the factoring of a trinomial special case when the leading coefficient is 1. So when you multiply leading coefficient A and C, the product ends up being C. So you want to list all of the factor pairs of the constant, then choose the factor pair that adds up to B, and the solution will be x plus one of those factor pairs times x plus the other factor pair. But if you're not sure what to do, you can just factor by grouping. So here we have x squared times 13x plus 30. So leading coefficient is 1. 1 times 30, the product is positive 30. So we'll be looking for sum. We need two factor pairs of 30 that adds up to 13. So we have 1 times 30 will give us 30. The sum is 31. That's too much. 2 times 15 will give us 30. The sum is 17. Closer, but still too much. We can have 5 and 6. Well, the sum is 11. That's too little. We can also have 10 times 3. And this is perfect because the sum is 13. So now we can just rewrite this as 10x plus 3x. Keep everything else as is. Now let's factor these two. We can take out x. From here we can take out 3. So this will be x times x plus 10 plus 3, x plus 10. Now let's factor out the parentheses, x plus 10, x plus 10, x plus 10. So this and this will cancel and the whole thing will become x plus 3 times x plus 10. And this is our solution. But if you notice, we have plus 10 plus 3 as our factor pairs. So if your leading coefficient is just 1, that's a special case. Whatever the factor pairs are, you can take them and jump straight to the solution. So for example, here we have leading coefficient is 1. 1 times 5 is 5. We need two factors of 5. Well, it's a prime, so it's only 1 and 5 that will work. And it's a positive 5. So we are looking for a sum. And we need the sum to be negative 6. And the only way this will happen if we have negative 1, negative 5. Those two will have the same sum. So I claim that my solution will be x minus 1, x minus 5. It doesn't matter if you have x minus 5, then x minus 1. Order in multiplication does not matter, just like 3 times 2 is the same as 2 times 3. Since this is our first time, we're going to do it the long way too. So we have minus 5x minus 1x. Let's keep everything else as is. So I'm going to take out x from here. And I need to change signs here. So we divide by negative 1. So we have x minus 5 minus 1, x minus 5. Let's take out x minus 5. Whatever goes in denominators goes on the outside. This and this will cancel, so we have x minus 1 times x minus 5. And this is our solution. But remember, it only works if leading coefficient is 1. So here we have leading coefficient 1. So I just need to take last number, which is negative 27. Since it's negative, I'm going to look for difference. and I need two factors of 27 that have difference of -6. 27 literally has two sets of factors, 1 and 27, and these have difference of 26, which is too much. And the second set is 3 and 9, or 9 and 3. And these have difference of 6. We need more negatives. This will be positive. My solution for this will be, I'm going to use the shortcut, x plus 3, x minus 9, or x minus 9, x plus 3, those are the same. Since I am using a shortcut, I am going to check. Now this is my solution, and I want to check that x plus 3 times x minus 9 gives me the original problem back. So we get x times x minus 9 times x plus 3 times x minus 9 times 3. So we have x squared minus 9x plus 3x minus 27, and this will be x squared. These combine into -6x minus 27, and this checks out. That's all.